Hello guys, welcome to our walkthrough video. Here we can see our prototype of NETRA for problem statement of maximizing section throughput using AI powered precise traffic controller. So this is our simulation, मतलब prototype. So you can see we have a different types of trains and parameters for them. So hold, emergency, service, or and other things of that train have a parameter. So we can see we can change the route of a train from here if to improve the efficiency of train, or we can auto reroute through AI. So next we can see we have here quick section, quick actions. So we can quickly change the all parameters of train for our simulation only. Now this is our section tab where you can see different types of section, condition of that section, how many trains are on that section, and what is the condition of that section. Here is our route section where we can see routes of different types, and here is a timetable and schedule management tab where we can see the timetables of different train, and we can cancel the train if we want to improve the efficiency of the section. So here is a performance analytics tab where we can see the performance of trains, network efficiency and average delay and throughput of the section. Now if we start our simulation, we can simulate the real life situation of a section of a train management. So we can see a signal control, train is approaching onto a signal of some section. We can see that, we can control that. Now we can see here different types of parameters, if train is running, fuel, passenger, and is it on time or not. Or we can manipulate the parameters using that options in the rightmost side. Now we can see here different types of game mode. This is only for simulation only. In real world this will not be there. Now to stop the simulation we can just click on stop simulation and all things will be come to an halt, and we can see precisely.
Good morning, respected judges and fellow participants. I am Aditya Anil Tiwari of Team V Hackers. Our team ID is 86069. Today, we are excited to present NETRA, our AI-powered solution to problem statement 25022, maximizing section throughput using AI-powered precise train traffic control under the Ministry of Railway team. The Indian Railway operates one of the world's largest and most complex rail networks, running over 20,000 trains daily, yet delays cascade through the system. Energy is wasted and infrastructure capacity remains unutilized. Netra is here to transform railway operations through intelligent and real-time decision making. NETRA stands for Network Enhanced Traffic Real Time Automation. It represents a paradigm shift of how we think about railway scheduling. What NETRA is? NETRA is an intelligent decision support system that acts as a digital brain for railway traffic management. Think of it as having a chess grandmaster and a speed chess expert together. One planning moves ahead, the other responding instantly onto the board. Two-tiered AI approach. Let me explain our dual intelligence architecture. Tier 1 is our strategic planner. This is our long-term thinker using advanced mathematical optimization. The strategic planner generates optimal baseline schedules, planning hours and days ahead. It considers train priority and classification, status, capacities, and platform availabilities, maintenance windows and speed restrictions, historical traffic patterns and seasonal variations. Think of it as the railway master scheduler. The ideal world where everything runs perfectly. Our tier 2 is a tactical executor, but railway don't operate in an ideal world. Delays happens, weather changes, equipment fails. This is where our tactical executor shines. Using deep in reinforcement learning, it makes real life decision every few seconds, responding to unexpected delays and disruption, platform conflicts and track occupancy, emergency situation and priority changes, dynamic passenger demands. The tactical executor does not react, it learns every decision it makes, every conflict it resolves, feed back into a neural network, making it smarter with every passing day. What makes Netra truly revolutionary is how we combine three cutting edge technologies. First is our hybrid architecture. We merge mixed integer learning programming MILP for optimal planning with deep reinforcement learning DRL for adaptive execution. This ain't any using AI for the sake of AI. It's mathematically proven optimization meeting real world adaptability. Our second game, theoretic conflict resolution, is what we really stand for. When two trains compete for the same track, Netra just don't delay one randomly. We use Stackelberg game theory, modeling it as a leader-follower game where train priority, passenger loads, and downstream impacts are all factored into the decision. It's like having a fair referee who understands the game. Our third mathematical guarantees is that we don't use any black box AI solution. Netra provides provable guarantee on stability, optimality. We can mathematically demonstrate that our schedules won't cascade into chaos, and we are approaching the theoretical beamless solution. This combination has never been attempted in railway scheduling before, and that's what makes Netra a breakthrough. Our methodology and technical approach goes like first, we are assigning the train on priority networks. Is the capacity less than forecasted train? If it is yes, is the link overlapping with SDN or GQ/GD corridor? If it is if it is overlapping, the proposal according to SDN and GQ criterion again goes to the train assignment on priority. If it is not collapsing, it is the link acting as a feeder to DFC? If it is no, then if it is yes, then the two line separation operation for freight is provided. Again, it goes on the train assignment. If it is no, then is the existing capacity is less than the forecasted train. If it is no, then no intervention is required. If it is yes, then we are adding an automatic signal. And if the new capacity is less than the forecasted capacity, we are adding one more line to it. If it is no, then also we don't require any uh, changes. Moving upon the feasibility and viability, let's address the elephant in the room. Can this actually be built and deployed? Absolutely. Here is why. Feasibility, why will Netra work? Proven algorithm have been founded in Netra, like MILP has been used for optimizing industrial processes for decades. DDQN is proven reinforcement learning architecture used in robotics and autonomous systems. ADMM is widely used in distributed optimization problem. These aren't experimental techniques, they are gold. In their respective field, we are applying them innovatively, but the underlying science is solid. Indian Railway has already significant IT infrastructure, data centers at zonal headquarters, railway traffic management system, RTMS, in major sections, real-time tracking systems. Netra is designed to integrate with these systems via standard APIs. We are not asking railways to rip out and replace. We are building a layer that sits on top, enhancing what already there. Scalable deployment. We can start small, like phase one is our pilot on single high density section, Delhi Ghaziabad corridor. Then we can expand to an entire zone. Then we can plan the national rollout and zone specific configuration. Each phase validates the system, builds confidence, and generate data for our next expansion. We are not naive. Deploying AI in critical infrastructure comes with a challenge. Here's how we address them. The first challenge is AI are only as good as their data. Poor quality of data leads to poor decisions. Our solution is that we use digital twins to generate synthetic training data, reducing dependency on incomplete historical records, implementing phased rollout, starting with sections that have already good data collection, building in validation layer that flags anomalies before they reach AI. Our second challenge comes out to be the inexperienced railway dispatcher might resist AI recommendations, seeing it as a threat to their expertise. Our solution to this is we are positioning Netra as a decision support system, not an autonomous control. Human always have the final say. Comprehensive training program that explains why behind the recommendation. Include a support phase where AI researchers work alongside the dispatcher to build the trust, showcase early wins, and quantify the approach. The viability of this system we are making is the deployment cost will be comparatively low and the maintenance will be minimal with the open source component. Compare this to the benefits, we'll demonstrate the next billion in energy saving and deferred infrastructure. The ROI is measured in months, not years. Coming to the impacts and benefits, the punctuality would increase to 95%. Currently, Indian Railways averages around 75 to 80% punctuality on many routes. Netra targets breaking the 95% barrier. You may ask how. Our answer to this is proactive conflicts prevention, not reactive scrambling, intelligent delay absorption, distributing small delays across multiple trains rather than accumulating massive delays on one. Predictive maintenance integration, rerouting trains before track section fails. Imagine passenger experience knowing your train will arrive within 5 minutes window almost every single time. That's what Netra delivers. We, the railways, spend 20,000 crores annually on energy. A 15-30% reduction means 3,000 to 6,000 crores saved every year. How does Netra achieve this? Optimal speed profile that minimizes acceleration braking cycles, regenerative braking coordination where the train breaks downhill while other accelerates uphill on the same electrical section. Coasting algorithm that uses momentum intelligence reduced idle time at signal performance. This is in theoretical. Similar system in Europe metros have achieved this reduction. The higher throughputs in the Indian railway infrastructure is near the capacity on major routes. Building new track costs thousands of crores and takes decades. Netra increases cost effectivity, reduces safe separation distance through the precision control, optimization platform, utilization at busy stations, smart overthinking strategies on multiple track section, and better track freight passengers. Coming to the last, that the NETRA impacts extend far beyond the railway network. It touches every aspect of the Indian economy, society, and environment. Coming upon the research and the references, Netra isn't built on hunches on guesswork. It's grounded by rigorous academic researches and proven methodology. We have conducted an extensive literature review of 20 research papers spanning mixed integer linear programming for railway scheduling, deep research learning in transportation system, multi-agent optimization and game theory, real-time decision making under uncertainty. Our complete literature review is available in Google Sheets, and we have prepared an extended documentation in Google Doc that very detailedly explains our algorithmic choice and its academic justification. To conclude, Netra represent more than just a technical solution. It's a vision for the future of Indian Railway, a future where passengers travel with confidence, not anxiety. Energy is used intelligently, not wasted. Infrastructure capacity is maximized, not exceeded. Safety is guaranteed, not compromised. We combined cutting edge AI with proven mathematics wrapped in a practical deployable system. Netra is ready to transform railway operation not someday but today. Thank you for your time attention. We are excited to answer your question. Demonstrate how Netra can revolutionize Indian railways. We are team hackers making railways smarter, one decision at a time. Thank you very much.